When I'm teaching paddlers about rope work, I find that initially they think it just looks like a pile of spaghetti. In this chapter, we're going to teach you some clear and concise rope work that'll help you in most situations you would encounter in your paddling.
We're going to consider our options for retrieving equipment from the river. And using an example of a kayak stuck in the flow, we'll introduce several systems that help us maximise our efforts using a selection of basic rescue kit.
So before we can recover any equipment from the river, we need to attach a line to the item. So here we're going to get a line onto Dougie's broached kayak. Dougie's going to wade out and carefully attach the line onto the attachment point, the broach loop. Then he's going to come back to the bank and we'll just try and give it a haul.
When you haul on a line to get maximum pulling power, just get every available person to join in.
It's not actually budging. So it would appear this boat is really stuck.
If we secure our haul line to an anchor with a clove hitch, we can pull on the middle of the rope. This has the potential to hugely increase the forces applied. However, the direction of pull is crucial. If hauling on the line or applying a vector is not working, we need to consider mechanical advantage systems. First, we'll show you the simplest and most effective system, the Roving 4-to-1.
We're demonstrating this system in dry land so that it's clear. We're going to attach a carabiner to the broach loop on the front of the boat. We'll run the rope through that carabiner. We'll bring the bag end back towards the anchor, where we clip in this end of the rope, creating a system with theoretical 4-to-1 mechanical advantage that's easily resettable. This system uses one rope, no knots, and is very simple.
Let's take a look at the Roving 4-to-1 in practice.
So this time, Dougie's going to attach a carabiner to the actual rope, but leave it free to run. That carabiner will be attached to the rescue point on the boat. Now Dougie's going to run the bag end of the rope back. This piece of the rope will be attached through the carabiner at the anchor and run back down to the carabiner at the bag.
To recap, we attach the carabiner with the rope run through it to the boat's rescue point. The other end of the rope runs through the carabiner at the anchor. Finally, the clean end of the rope is run through the carabiner on the throw bag itself.
We now have a system which offers theoretical 4-to-1 mechanical advantage, which can be reset when loose to get the bag as close to the boat as possible. Then me and Dougie can haul on it to remove the boat quicker and easier. And if need be, we can reset the bag and haul on it again.
As another option, we can apply the same 4-to-1 system as an external or piggyback rig using a sling.
If we have our line attached to the boat and we can't pull it, and using a vector we can't get it in, using the equipment we carry, we can simply place a prusik onto the line, then run our line from the prusik through another carabiner attached with an overhand knot, through the carabiner at the anchor, and then by completing the loop and passing through the other carabiner, you create a theoretical 4-to-1 mechanical advantage system which you can haul your trapped equipment back in on.
This external or piggyback system allows the user to secure the haul line and remove the mechanical advantage system without losing attachment to the boat. If you have less rope available and you need more of the haul line to reach the boat, you can consider using a Z-drag.
With this system, we're going to create a 3-to-1 mechanical advantage. We're going to clip the bag end onto the boat. The haul line comes back to the anchor, runs through the carabiner, and returns to another carabiner attached with a prusik as far down the haul line as we can get.
This system doesn't give you as much force as the previous examples, but it is an option when you have less rope available. Let's see it for real.
So Dougie's attached the prusik to the haul line and a carabiner with a pulley. Now we release the clove hitch and attach the other end of the rope that's through the carabiner at the anchor, through the carabiner at the pulley on the prusik.
The Z-drag will require more effort to haul on, and you need to be aware of wet prusiks slipping on wet rope.
To give you an extended reach to attach to a brooch loop, you can use a couple of rubber bands, the throw bag, the carabiner on the end, and a paddle, creating a paddle hook.
When the carabiner is pulled against the brooch loop, the paddle slips out of the rubber bands, leaving the line attached to the boat and the rubber bands on the carabiner. Once we have recovered people's equipment, we often find that, for example, a boat and its owner may be on opposite sides of the river. When that is the case, we need a paddler on the same side of the river as the lost equipment to attach a line and send the equipment on its way. Here the team keep the rope high while it's clipped to the boat. Then communicate, agree, and work the boat back to the bank that its owner is on. Remember that the needs of you and your team outweigh the needs of the equipment. So if possible, get a line across the river to the equipment and bring it back to the paddler. Recovering equipment can be carried out reasonably slowly and methodically. As you have seen, this allows for complex use of the rope. Remember, it's only kit, and we shouldn't be taking big risks to recover bits of plastic.